Closely related to methods and generic methods in .NET are delegates and generic delegates. Because a delegate, you might remember, it's a type that I can use to define variables that point to other methods. It's a type that essentially describes a method signature with its return type. So I can create variables that point to other methods and invoke those methods indirectly through my variable and do so in a type-safe way. So lots of words there, but let's work through this backwards. Let's imagine that inside of dump, I don't feel comfortable using console.writeLine directly. Instead, I want dump to just be responsible for iterating properly through the buffer, picking out each item, and then using some layer of indirection to actually print the item. Where does print come from? Well, I could have someone from the outside pass me in a variable print, and I'll use that variable like a method by applying parentheses to it, invoking it, passing in an item. The question is, what type is print? Well, because I want to use print like a method, print will have to be a delegate. Let me create a delegate, a public delegate using the delegate keyword. And when you define a custom delegate like this, you're essentially defining the type of method that you want to be able to reach through this delegate. So I need a method that doesn't have a return type, doesn't need a return type. So let's say the return is void. And then the name of my delegate will be printer. And if I didn't want to take any parameters, that would be a perfectly reasonable delegate definition. But I actually want to be able to take a parameter. Let me just say that this method has to take an object reference, and we'll call the parameter data. And now I have a new type, a type called printer. I can define parameters and variables of that type. So let me take a print variable of type printer to this method. And now dump is perfectly happy. The C# compiler is happy. I have a layer of indirection between dump and the ultimate output. When it calls print item, it doesn't know if it's writing to the screen or to a file or to a database. All it needs to do is iterate through the items correctly and call print for each one. So back in the program, when I invoke dump, I now need to give it a delegate parameter. So I need something that is of type printer, and let me just call this console out. But what is it equal to? Well, let me define a method to point to. And when you're using a delegate, you can point to instance methods. You can also point to static methods. Since I'm already in a static method, I'll define another static method. And what I need is a method that essentially matches the type signature and return type shown here. Doesn't have to match the name, just the return type, and then the types and the number of parameters. So return void, take an object parameter, and then do something interesting with it. For instance, WriteLine the data, and that will take care of calling toString for me. So console out is a variable that I will use to initialize a new printer, point it to console write, and then I have something that I can pass to dump, console out. And if I do a build at this point, the C# compiler is perfectly happy. I've created a printer, initialize it, to point to a method, console write, passing that into the dump method, which will use it. So if we run the program, after I take out some of this other extraneous output, what we should see is that I can input 2.1 and 3.4, and those are still dumped out and printed to the screen correctly. Now, of course, when dump goes to invoke print with a double value, since print takes an object reference, we'll once again be in a situation where some boxing occurs. How could I avoid this boxing? Well, I could do it by strongly typing the printer delegate using generics. So just like we can have generic classes and generic methods and generic interfaces, delegates too can have generic type parameters. So I want a printer of T, where T is the type of incoming data. I can now use T throughout this delegate definition for any parameters that I want. I could also use it as a return type if I wanted this method to return data, which I don't really need, so I'll leave that as void. And now for the dump method, I no longer have a printer type. I do have a printer of T. And where's the T going to come from? It's not going to be something that I hard code here. Instead, if I have a buffer of T, and I'm calling this extension method dump of T on that buffer, then I want the printer to also use that generic argument T, whatever is passed in for that. So with an iBuffer of double, I'll have dump of double and a printer of double. And you can see that this code is perfectly happy. Coming back into the program, I now need a generic type argument here to say I want a new printer of object. Just stick with me for that for a second. And maybe I'll use type inference in the var keyword to say yes, make console out type printer of object. And now you'll see how all the type checking works at compile time. I have a printer of object, And that delegate is perfectly happy to accept a method like console_write that takes an object parameter. But now the dump method, trying to pass a printer of object to the dump method that's working on a buffer of double, that's not going to make the C# compiler happy. So what I really need is a printer of double. And of course, that will make the C# compiler happy when I invoke the dump method. That's the type of printer it's expecting. But the line that initializes the delegate is unhappy now because console_write doesn't match that type signature. It needs to work on items that are typed as double. So once I make those few changes, everything is happy. And it turns out I could just take console_write and pass that directly to dump. And behind the scenes, the C# compiler will be smart enough to instantiate a delegate for me and initialize everything so that the delegate is pointing to that method. And now if I run this program, there shouldn't be any visible difference in the way this behaves. But we are now using a strongly typed delegate. That will help me prevent boxing, and that will also provide some additional type checking as I'm building up this application. And ultimately, delegate types are extremely useful in .NET. With delegate types, I have a way to invoke methods through a layer of indirection, through some sort of variable that could point to different methods. And this is so useful that there's a number of delegate types that are already built into .NET. There's enough delegate types around that I don't need to define my own custom delegate here called printer. So let's explore those delegate types next.